So in question 8, we've been given that 9 sine square theta plus sine 2 theta equals 8. And using this, we now have to show that 8 cot square theta minus 2 cot theta minus 1 is equal to 0. So this is a classic sort of changing the format trigonometric question. And so let's jump ahead right into it. So if we have 9 sine square theta plus sine 2 theta equals 8, our first step is to get rid of this 2 theta here. To bring everything in terms of a single theta. So we know that sine 2 theta is just equal to 2 sine theta cos theta. So I can go ahead and rewrite the first this equation in the following way. So I have 9 sine square theta plus 2 sine theta cos theta, where I just replace this with this, and this would be equal to 8. Now, I realize here that I need to get everything in terms of cot, and I know that cot is cos divided by sine, so it's just 1 upon tan. And I see that the way to do this in this equation is to divide through by sine square theta. So if I go ahead and do that, essentially what I would get is sine square theta on the outside, then I have 9 plus 2 cos theta upon sine theta, and this would be equal to 8. Now, we know that cot is indeed cos theta upon sine theta, and also when I move this sine square theta over to the other hand side, this would become 1 upon sine squared theta, which is just cosec squared theta. So I can go ahead and simplify this equation even further. Essentially, I will get 9 plus 2 cot theta would be equal to 8 cosec squared theta. Now, again, all of our terms here are in terms of cot, and we have this cosec squared term here, which is a bit annoying. And to get rid of that, we can use the identity of cosec squared theta being equal to cot squared theta plus 1. So if I go ahead and write that down, essentially my equation looks like this. So that's 9 plus 2 cot theta would be equal to 8 times cot squared theta plus 1. And then I can go ahead and expand and simplify, and I get 9 plus 2 cot theta would be equal to 8 cot square theta plus 8. And now just rearranging this equation, I'll move everything on the left hand side over to the right hand side, and I get 8 cot squared theta minus 2 cot theta, because this positive 2 cot theta will become negative on the other side. And then I'm bringing negative 9 over to the right hand side as well. So 8 minus 9 would be equal to 1, and this means the other side is equal to 0, hence shown. So for question 8b, we have been asked to hence solve the equation 9 sine square theta plus sine 2 theta is equal to 8 within the interval of theta being between 0 and 2 pi, giving our answers correct to 2 decimal places. So now from part A, we know that we can rewrite this equation as follows. Well, we can rewrite this as 8 cot square theta minus 2 cot theta minus 1 is equal to 0. And this obviously is a quadratic equation in terms of cot. So if you solve this using a calculator, you will find that cot theta is either equal to minus 1 upon 4, or cot theta is equal to a half. And this obviously does mean that tan theta would thus be equal to minus 4. And for here, it would mean that tan theta would be equal to 2. So we've got two sort of sets of tan theta's answers here, and we can go ahead and just use our tan inverse law to help find our answers. So for this left-hand side, where tan theta is equal to minus 4, if I was to take the tan inverse of minus 4, I get the answer of theta being equal to minus 1.326. Now, of course, this does not fall within our interval of 0 and 2 pi. So I can go ahead and add the period of tan, which is pi. So if I go ahead and add pi here, so theta would also be equal to minus 1.326 plus pi. This would yield me the answer of 1.82. Now, of course, I'm going to just go ahead and reject this negative answer for theta. Now I have the value of 1.82. I can also add another pi to this because it falls between the interval of 0 and 2 pi, and since tan's period is actually pi, another answer for theta would be 1.82 plus pi, and so that would equal to 4.96. I can't go ahead and do this again because then that would lead me to having theta above 2 pi, and we're not allowed to do that as per the question. So I have two values for theta here and here. So now we do the exact same thing for the other tan theta answer. Well, so here tan theta is equal to 2. I can take the tan inverse of 2 to find theta, and here if I take the tan inverse of 2, I get theta to be equal to 1.11. Again, in order to find all the answers for theta in the interval, I can go ahead and also add pi to this answer. So if I go ahead and add pi to 1.11, that gives me 4.25. And again, can't go ahead and do this again because that would leave me outside the boundaries of this interval. So we know that we now have 4 answers for for theta. Understanding that we cannot use this negative value for theta because it falls outside our interval. So finally, our answer for theta would be equal to 1.11, 1.82, 4.25, and 4.96, hence solving this question. So finally, for the last part of question 8, part C, we've been asked to solve the equation 9 sine squared of 2x minus pi by 4 plus sine of 4x minus pi by 2 is equal to 8. Within the interval, x is between 0 and pi by 2, giving our answer to 1 decimal place. So just looking at this equation, we know that our theta in this case is 2x minus pi by 4, since this is just double of the initial theta. And so we can go ahead and, well, we know that we can rewrite this equation in our cot form. Now, we've already solved what theta could be in this equation, and so we can just go ahead and input our same value. So we know that, so from part B, we know, so from B, theta is equal to 1.11, 1.82, 4.25, and 4.96. So we thus know that 2x minus pi by 4, which is our theta in this question, would be equal to 1.11, 1.82, 4.25, and 4.96. So we can go ahead and just rearrange this equation to find our value for x. So if I go ahead and plus pi by 4 to all of these answers, I get 2x is equal to 1.895, 2.61, 5.04, and 5.75. And then if I divide everything by 2 in order to get our value for x, I get that x is equal to 0.9475, 1.305, 2.52, and 2.875. Now, just looking at our interval, we can cancel out these two options here, and so we know that x is equal to 0.9475 and 1.305. And since we are supposed to give our answer to 1 decimal place, we know that answer for x would be 0.9 and 1.3, hence solving this question.